Okay. Please do write it. Let me know when you are done with this. And then we are going to talk about the next application. The next application is whether compound exists as mononuclear. Mononuclear, that means one central atom, or polynuclear, that means more than one central atom. Polynuclear. This is the next application. Please do write this up to this.
Done, sir.
Okay. Now see. First, you need to calculate the EAN for me, and EAN for this you are going to calculate CO, cobalt, and CO, carbonyl 4. Tell me whether tell me the EAN, effective atomic number of this compound. I want answer from you, Humam. Austin, you can send the message. Yeah, it's no. Austin, check the calculation. Very good, Austin. Humam, should I explain it? Humam, EAN has a formula. Again, I'm going to write it. Atomic number minus oxidation state plus 2 into coordination number. Can you tell me the atomic number of cobalt? That is 27. Minus oxidation state. Humam, can you tell me the oxidation state of this cobalt in this complex compound?
-1.
-1. Cobalt X. How many cobalt carbonyl is there? 4 into it is 0 is equal to 0. X will be equal to 0. Please do calculate it.
Okay, sir.
So 27 oxidation state is 0. Can you tell me the coordination number? What is the coordination number, Humam?
I don't know, sir.
Why you don't know? What is coordination number? Coordination number is basically number of coordinate bond. That means you are not revising, right? Number of total coordinate bond. Why the problem to calculate coordination number? Number of total coordinate bond. How many CO ligand is there? How many ligand is there? Umam,
4.
4 ligand. CO is monodentate, didentate. What it is? How many bond one CO can make?
Monodentate 1.
One it can make one. One CO will make one bond. So 4 CO will make how many bond?
4. 4.
4. So what is the coordination number?
4.
4. It is so simple. Still you are not able to understand. Have you got it? Yes or no?
Yeah, got it.
So 2 into 4, that will be equal to 27 minus, 27 plus 4 to 8. What it becomes? 35. Yes or no?
Yes.
Now, if I will ask you whether it is oxidizing agent or reducing agent, what it will be? Oxidizing agent or reducing agent? This you need to remember. So it is nearby 36. Yes or no?
Yes.
Now it wants to get 36 electrons. So it will gain one electron. Gain of electron is called what? Reduction. And the one which reduces is called oxidizing agent. Are you getting my point?
Yeah, yes.
So if the question is about oxidizing agent and reducing agent, this is a oxidizing agent. But here the question is about mononuclear, polynuclear. Here it is mononuclear. When it is mononuclear, the effective atomic number is 35, but it wants to be 36. So basically, it will be dinuclear. Dinuclear. You can see CO whole 4 directly. I'm going to write it. Here it will be CO whole 4 and CO whole 4. Now you can see initially it is 35, but by making one bond, it becomes 36. One of this electron 36 and one of this 36. And this bond is called delta bond. Are you getting my point, both of you?
Yes.
Write it. Austin, it is dinuclear, right?
Yes.
So the formula will be CO2 CO whole 8. Dinuclear it is. So in order to get a stability, CO whole 4 exists as CO2 CO whole 8. Let me know when you are done with this. Oh, mom, if you still don't understand how to calculate EAN, let me know.
No, so I got it.
Okay, let me know when both of you are done with this. Sir, is EAN part of coordination component? After because we didn't learn this in school. Basically, it is not in NCERT. It will be asked in your JEE Mains and very a small topic it is. So that's why I discussed this.
Yes.
Isn't it? Okay. And it is a very easy topic, right? Humam,
Yes, I got it.
feel free to ask anything, Humam, and you can ask anytime, and you can ask many times as well. Tell me whether it is mononuclear, binuclear, trinuclear, what it is. It will all be calculated only uh, with the help of EAN, effective atomic number. First, calculate, Humam, effective atomic number of this. Sometimes my Wi-Fi gets a stop, like means basically due to power cut off. So wait, if anything happens like that, don't leave the meeting. Umam, very good. The answer is correct. You can see EAN is equal to atomic number. You know 27. 27 it is, and oxidation state 0. The coordination number will be 2 into 4. So it comes out to be 36. Right?
Yes.
So if it is 36, that means it is same as noble gas atomic number. So it is stable. It will be mononuclear. Are you getting my point, both of you?
Yes.
Very easy. The next I'm going to ask you the last one. This has been asked in NEET basically. FeCO whole 5. Mononuclear, dinuclear, tetranuclear, trinuclear, what it is. This is mononuclear you have sent at that is for NiCO whole 4, right?
So, Fe.
Humam, did you calculate this for FeCO whole 5?
Yes, sir.
Do you know the atomic number of iron? Yes or no?
Yeah, 26.
26. What is the oxidation state, Humam?
Zero.
0. Very good. So what we are going to do, very simple. You got the right answer. 26 minus 0 plus 2 into 5, it becomes 10 plus 26, 36. So it will be mononuclear. That's a good answer, right? Okay, tell me about this. FeCO all four. Whether it is mononuclear, dinuclear, or trinuclear. Very good, Austin. Any answer for you, Mom? Very good. Both of you got this. How to solve it? It's very easy. Now the third application and the last application, whether that means metal bond exists. Oh, wait a minute. Is it dinuclear? Did you find it dinuclear? Both of you?
Yes, sir.
Okay, tell me EAN of this. Iron 26 minus 0 plus 2 into coordination number 4. So it comes out to be 26 plus 8, that is 34. Yes or no?
Yes.
35 you have written. No. 34. Now, if one iron, since it is talking about only the nuclear, one iron gets connected with another iron. So from 34, it comes out to be 35, but we need 36, right? EN should be 36. So this will combine with another iron. So now it is 36. In order to get this as 36, you have to do this. So this is your trinuclear, isn't it? From you can see for 35 it is, to get 36, it becomes dinuclear. So for 1, it becomes dinuclear. So for 2, it becomes trinuclear. Are you getting my point, Humam? Austin?
No,
Yes,
sir, I did not get it.
Okay, Humam, have you got this, the previous one?
Yeah,
See,
previous one.
what was the atomic EN that we got? That is 35, but it should be 36, right? So it combined with another cobalt to make itself 36. Got it?
Yes.
It increases by 1. So as you can see, for iron, you got the EAN 34. So one iron will combine with another one. So now it will have 35. Yes or no? 35 and 35, from 34 to 35. But we need 36 EAN. EAN should, the value of EAN should be 36, right?
Yeah, yes.
So this will combine with another one. Now, after making 2 bonds with iron, it becomes 36. So again, this is 35. So it will bond with this. So it becomes 36 now. So that's why it will be trinuclear. Are you getting my point?
Yeah, yes.
Humam.
Yes, got it.
So this becomes Fe3CO12. Tri, we are going to do tri. Let me know when you are done with this.
Done, sir.
Wait. Now, the third application, whether MM bond, that means central metal bond will be there, exist or not. So very simple it is. If I will give you CO whole 4, this is your cobalt, small o, and these are capital both. So you know EAN that you got is 35. In order to stabilize itself, what it will do? It will twice. That means dinuclear it becomes. So from here you can see easily that CO bond exists, so it exists. So very simple these are, right? Yes or no, both of you?
Yeah, yes, sir.
Yes.
Let me know when you are done with this.
Done, sir.
Now we are going to start Werner theory, the first theory in NCERT that you have studied. Basically, this was the first theory. This was the first theory given for complex compound or coordination compound. So bonding in coordination compounds. Bonding in coordination compounds. And the first theory is about Werner's theory. Werner's theory. So what does this Werner's theory says? We will talk about this, and this is very limited. Werner theory is all about coordination number 6. That means it will have 6 coordinate bond. Very simple. So I'm going to write it right with me, then I'll explain it. According to Werner theory, central metal atom have two valencies. One is your primary valencies and another is your secondary valency. One is your primary and another is your secondary valency. Now see what happens in primary valency. This is similar. Basically, I taught you that part first, the recognition of complex compound, because this is very easy to understand after that. Primary valency is equal to oxidation state, is equal to oxidation state of central metal atom, CMA. And secondary valence, first I'm going to write about all this. Okay, let it be. Secondary valency is equal to coordination number, is equal to coordination number of central metal atom. So basically this secondary valency is ligand. Coordination number comes from where? Ligand. So this is what he said initially. The second point you can see, satisfied by anions, satisfied by anions. As you can see, metal has positive oxidation state, so it will be satisfied by negative ion. And this is satisfied by ligands, satisfied by ligands. How many ligands need to attach with central metal atom to satisfy central metal atom? The third point is it is non-directional. It doesn't have any direction because it is attached with positive and negative charge. That means basically force of attraction between the opposite charge. But this is directional. This is like an ionic compound. Ionic compound doesn't have direction, but covalent compound does have, because sharing of electron take place, overlapping of orbital take place, and orbitals p we have direction for that. We have orientation x, y, z, and this is basically directional. This is your ionizable, ionizable. It can be ionized, and this is non-ionizable, non-ionizable. So as I told you, when we started complex compound, double salt, addition compound. Addition compound is of two types. One is double salt, another is complex compound. Complex compound is the one which retain its property in aqueous state as well as in solid state. So basically, I told you that in a square bracket, it will not dissociate, but after a square bracket, outside of a square bracket, it can dissociate, because that outer square, after a square bracket, whatever present comes to neutralize the complex compound. So you can take this primary valency outside the bracket, whatever is present, and secondary valency inside the bracket. That means basically ligand after central metal atom. But that time he told us that satisfied by anions. That means positive, primary valency is positive, so it is satisfied by anions. Limited compound that had we had that time. Please do write it. Let me know when you are done with this. One more point is there to add in this. Let me know when you are done with this.
Done, sir.
Now the next one is not helpful in geometric prediction. Not helpful in geometric prediction. And this is your helpful in geometry prediction. Helpful in geometry prediction. Very simple it is. The last point was this. So you know that only this ligand comes into play for the geometric products prediction, not the outside the bracket like that. And for shapes, I'm going to write a point here. According to Werner, all secondary valencies have shapes. Arrangement according to coordination number. So if there is anything that you don't understand, please ask me. And this theory is only for Werner theory is all about coordination number 6. Let me know when you are done with this.
Done, sir.
Okay, what I told you, Werner theory is all about, you can write in bracket here, coordination number 6. Coordination number equals to 6. Write it as well. So very simple it is. Now see how what type of question they ask. They will ask you like this: CONH3 whole 6 Cl3. If you are going to react this with excess of AgNO3, then they will ask you number of moles of AgCl precipitated. Number of moles of AgCl precipitated. So how you are going to solve it? Very simple. What you need to do, see how many total after central metal, how many these are there. So this much, this is present 3 and 9. So you are going to make 6 as ligand, coordination number 6, and all of them as out of the bracket. And now when you are going to react this with AgNO3, and since you know that this is in excess, this part is non-ionizable, as you know that this part is non-ionizable. and this part is ionizable. Everyone knows that chlorine will go in Cl minus and Ag will come in Ag plus. Now, how many chlorine is there? 3 chlorine and Ag is in excess. So these two combine with each other and you will get 3 moles of AgCl. 3 moles of AgCl. Is that clear?
Yes, sir.
So this is how you are going to do it. You can do like this as well. CO, NH3, Cl3 and NH3 whole thrice. But in the question, they told you, sorry, in the Werner theory, it was, it has been said that the primary valency outside the bracket should be anion. That's why I took this out, not NH3. Is that clear?
Yes, sir.
Please do write it. Hmm.
You're done, sir.
Very good. So you can make different criteria for this. First of all, experimental evidence of Werner theory, I'm going to tell you. Write with me. Experimental, this is the topic. Experimental evidence of Werner's theory. Experimental evidence of Werner's theory. Write it. Precipitation of primary valencies on the addition of a suitable reagent. Like if we are going to take an example, FeNH3 whole 6 Cl3. When you are going to take this, what will happen? 3 moles of AgCl, 3 moles of AgCl in the form of precipitate, on addition of AgNO3 solution. If you have AgNO3 solution in excess, and when you are going to react this with this, so 3Ag will come into contact with 3Cl minus and forms 3 moles of AgCl. If you want to see the reaction, I'm going to show you. FeNH3 whole 6. I told you the coordination number is fixed to 6. That is very good for us. Cl3. Now in water, what happens? This will be dissociated, only this part, not inside the bracket. So it will be converted into FeNH3 whole 6 plus 3 plus 3Cl minus, and Ag plus 3Ag plus comes from here and combined to form AgCl. Are you done with this?
Yeah, done.
Okay. Austin, the next practical evidence, experimental evidence is this. Electrical conductance of complexes. So basically, you know that if more ions will be there, electrical conductivity increases. Electrical conductivity, we can write directly proportional to number of ions. Directly proportional to number of ions. So very simple. I'm going to take the electrical. This is electrical conductance of aqueous FeNH3 whole 6 Cl3 is greater than that of aqueous solution, greater than that of aqueous solution of FeNH3 whole 5 Cl2. Why it is so? So I'm going to show you. Very simple it is. So if you're going to put this in water, FeNH3 whole 6 Cl3 in water, you know what will happen. Fe, just wait a minute, please. FeNH3 whole 6, and here comes plus 3, and here comes 3Cl minus. Yes or no? And if you are going for the next one, this one. Now, if you are going to add water in this, what will happen? This will be converted into FeNH3 whole 5 Cl plus 2 Cl minus. So how many ions there is? 3 plus 1, 4 ions. And how many ions there is? 2 plus 1, 3 ions. So if you are going for electrical conductivity, so experimentally we found that, let's say this is your A and this is your B. So A will have more electrical conductivity than B because it has more ions. Simple. Got it, both of you?
Yes.
Please do write it. Let me know when you are done with this.
Done, sir.
Very good. I'm going to give you two more options. Here it is. Can you explain this? Yes, 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 yes. See, first, this is the scenario. What we have is COCl3, 6NH3 is given. Now, what you want to do? CO is the central metal, and this can be ligand. Now, which one of them will be ligand? That is very important. NH3, whole 6, Cl3. What I told you is that the primary valency outside the bracket should be anion. It cannot be neutral or positive. That's why I took all this Cl3 outside. If you are going to write it like this, NH3 whole thrice, and your heart says that Cl3, and keep this NH3 outside 3 times. So this will be wrong. You are not going to do this. Primary valency is your anionic ligand. So now see, if you are going to react this with AgNO3, excess AgNO3. So you know that from here, Cl3, that means it will give you 3 Cl minus, and this is in excess. So we can take whatever amount we need or required. So we are going to take 3 Ag plus, and it will give you 3 AgCl, 3 AgCl. Is that clear? So that means from the first one, you are getting 3 moles. Now from the next one, you can see CO NH3 whole 5, that is confirmed. You're not going to take this out, but you can take Cl or anything inside the bracket, and what is left outside? Cl2. Now from here, you will get 2 Cl minus, and AgNO3 is in excess, so you can take any amount, whatever you required. So what will form? 2 mole of AgCl, 2 mole of AgCl. And the first one, from the first one, you can see CO NH3, first you are going to write 4 times, then 6 coordination number should be 6, that is fixed, I told you. So Cl is 3, 4 coordination number we got, now make it 6, 4 plus 2 6, only 1 chlorine is there, so Cl minus and Ag plus. So how many moles of AgCl? 1 mole. So what will be the answer? First 3 AgCl, 1 AgCl, wrong. 3 AgCl, 2 AgCl, 1 AgCl. So the answer will be B. Are you getting my point, all of you?
Yes.
Yes.
Let me know when you are done with this. Are you done with this, both of you?
Yes.
What about you?
Yes.
Where is? Please do this. Mom, self-study is very important. Whatever I teach or any teacher teaches, just do revision at home after class. After taking rest, you should revise each and everything. It won't
Yes.
take much time. Which of the following will not give test of chloride ions? That means basically in which of the following AgCl will not precipitate out? Any answer, both of you? Very good, Austin. Any answer from you, Humam?
No, sir.
Okay, see, no. So chloride test ion, you can see not give test of chloride ion. That means Cl minus does not form. In which case? Now, first case, if I'm going to take the first case, Humam, try to concentrate. So you know CO. NH3 is there how many times? 4 times. So NH3 4 times. And how many chlorine is there? 3. Now coordination number is 4. So you can take only 2 chlorine inside because coordination number I told you will be 6 only. Now one of the chlorine left, so you are going to take it out. Now when you are going to put this in water, what will happen? This chlorine will be ionized, yes or no? Humam.
Yes. Yes.
So this will give you test of chloride ions. So this is not the answer. Now for the B part, you can see CO. How many NH3 is there? 5. NH3 5 you can take inside. After this 5 coordination number, we need 6 coordination number. So Cl. How many chlorine is left? 2 chlorine. Now you are going to put this in water. Outside bracket easily it can ionized. After this, how many ions it will give? 2 Cl minus. Now since Cl minus ions it will also give the test positive test for chloride ions. Now the third one, CO. How many NH3 is there? 6 NH3. So 6 NH3 first we will take. After that, if there will be a space, then we will take chlorine. Now coordination number 6, that is already 3Cl. Now you are going to do H2O. Now you are going to dip it in water, 3Cl minus. So it will also show positive test. Now, after this, you can go for the D1, CO. How many NH3 is there? How many NH3 is there? NH3 is 3 and Cl is 3Cl. Now you can see that this is your situation. Now when you are going to dip this in water, you know that inside a square bracket, it doesn't ionize. So 0 Cl minus, there is no chloride ion. So this will be that option which will not give positive or which will not give test for chloride ions. Is that clear?
Yes.
Please do write it if you want. Let me know when you're done with this, Uma. Solvent isomerism is for water, right? It's not necessary there will be counter ion. See, if you are going to calculate the oxidation state, it is +3. Yes or no?
Yes.
Solvent basically counter ion comes into play for this. If there is any charge, then they come to neutralize it. And for Werner theory, since it is the oldest theory, at that time it was given that negative, it is satisfied by negative. So it will be positive. That's why it is negative. Okay,
Oh, yes.
please do write it. Let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Please do. Any answer, both of you? I'm going to explain this. First, you are going to calculate the oxidation number or coordination number. This is didentate, bidentate or didentate. That means alone it will make two coordinate bond. So this is also didentate. So total didentate is 3. So coordination number becomes 6. Yes or no? Both of you.
Yes.
Yes.
Now, if you are going to calculate the oxidation state of this M, let's take X plus 2 EN is there. EN is ethane 1, 2 diamine, which is neutral ligand. So into 0 plus C2O4 oxalato ion or oxalate. It has -2 charge. So -2 and only 1 is there. So into 1 plus chlorine is Cl minus. So we are going to take -1 as well equals to overall charge 0. So x plus 0 minus 2 minus 1 will be equal to 0. So what will be the oxidation state? That is equal to +3. And we need to calculate the sum of coordination number, that is 6 plus oxidation number. So 6 plus 3 is equal to 9. So the answer is A. Isn't it easy, both of you?
Yes.
Yes.
Okay, so this is it for today. And in the next class, we are going to start VBT, valence bond 3. Please read about this and then we will go ahead. Okay.
Yes.
Okay. Thank you.
Yes.
If you need any, if you have any doubt, you can ask me.